Welcome to this explainer. Today, we're stepping right into the fascinating geometric world of market mechanisms. We're going to explore how extreme consumer psychology physically shapes the economic graphs we use to make sense of the world. If you've ever struggled to perfectly diagram a supply shift for a high marks exam question, specifically those tricky ones on perfectly elastic or perfectly inelastic demand, well, this is exactly what you need. Let's see what actually happens when consumer sensitivity completely locks or unlocks market price changes.
Okay, let's dive into this with a question that kind of breaks the standard rules of supply and demand. Think about your own shopping habits for a second. What actually happens to a market when consumers absolutely refuse to pay a single penny more for a product? Or on the flip side, what happens if they refuse to buy a single unit less, no matter how crazy high the price goes? These are the absolute extreme boundaries of consumer behavior. And as you'll see, they create some pretty wild geometric realities on our charts.
Here's our quick roadmap for today's explainer. 1. The extremes of consumer sensitivity. 2. Panel 1, which we'll call the flat floor. 3. Panel 2, the vertical wall. And 4. Locked price versus locked quantity.
All right, let's jump right into part 1, the extremes of consumer sensitivity.
First up, we have what economists call perfectly elastic demand. In this state, consumers are infinitely sensitive to price. I mean, if the price goes up even a fraction of a cent, demand literally drops to absolute zero. Because they will only buy at one exact, highly specific price, it creates a very distinct geometric shape on our charts. It's just a perfectly horizontal, straight line.
Now, on the complete opposite end of the spectrum, we have perfectly inelastic demand. In this scenario, unlike that instant drop to zero we just talked about, consumer demand is completely unresponsive to price shifts. Whether the item costs $1 or, $1 million, buyers need it and they're going to purchase the exact same amount. Think of something like life-saving medicine. This creates the exact opposite visual on our graph, a strict vertical demand curve.
Moving right along to part 2, let's look at panel 1, the flat floor.
Now, what's really interesting about this slide is the precise geometry at play. Look at the demand curve there, labeled D. Notice how it's drawn as a horizontal straight line running completely parallel to the x-axis. This is our perfectly elastic demand. It forms a flat horizon line, basically a floor that the price rests exactly upon. Let's see what happens when suppliers try to change things up in this kind of environment.
Picture the action mechanics here. Our initial supply curve, S, intersects the flat floor at equilibrium point E0. But as we know, supply rarely just stays still, right? Let's animate a shift. If there's an increase in supply, the curve shifts rightward to S1. Our new equilibrium just slides smoothly along that flat floor over to E1. If there's a decrease in supply, the curve shifts leftward to S2, and our equilibrium slides back to E2. Notice what's changing on the x-axis below. The equilibrium quantity is shifting drastically from M0 to M1, or from M0 down to M2.
But here is the absolute core lesson of the flat floor. Because consumers are infinitely sensitive, check out the y-axis. The market price is totally locked at P. It remains completely unchanged. That supply curve can slide back and forth across that flat horizon line all day long, wildly changing the quantity of goods being bought and sold. But the price? It cannot and will not move off that flat floor.
That brings us to part 3, panel 2, the vertical wall.
Take a look at the demand line D on this chart. Notice how it's drawn as a strict vertical straight line, perfectly parallel to the y-axis? This represents consumers who are going to buy the exact same amount of a good no matter what. It essentially forms an immovable vertical wall right in the middle of our market.
Let's trace what happens when supply shifts in this scenario. We start at our initial equilibrium, E0. Now, if supply increases, the curve shifts rightward to S1. But it crashes right into our vertical wall, dropping the new equilibrium straight down to E1. If supply decreases, shifting leftward to S2, the equilibrium climbs straight up that wall to E2. The supply curves are literally just sliding up and down this immovable vertical barrier, which causes the price on the y-axis to wildly spike up to P2 or plummet all the way down to P1.
So, the crucial point is right here, in the source text. Consumer demand is completely unresponsive. Unlike our first scenario where the buyers basically held the price hostage, here the buyers are the ones who are trapped. They're entirely committed to buying the exact same amount, which means the suppliers' changing realities are what dictate these massive swings in the market price.
And what's the ultimate result of crashing into the vertical wall? The equilibrium quantity is completely frozen at M.
A change in supply brings about a change in price, and price only. The actual volume of goods moving through the market remains completely unchanged, locked firmly in place by that vertical barrier.
Finally, Part 4, locked price versus locked quantity.
And this brilliantly illustrates the real power of graphing these market mechanisms side by side. Perfectly elastic demand creates the flat floor, where the price is horizontally locked. But perfectly inelastic demand creates the vertical wall, where the quantity is vertically frozen. One extreme entirely locks the y-axis, while the other completely locks the x-axis.
Let's break this down into a quick summary table so it sticks with you forever. If your demand type is perfectly elastic, your visual shape is a flat, horizontal line, right? And the resulting unchanging variable when supply shifts, the price is locked tight. But on the flip side, if your demand type is perfectly inelastic, your visual shape is a vertical wall. And the unchanging variable there, the quantity is frozen. By simply associating the physical shape of the line with the variable it locks, you are going to perfectly diagram these concepts every single time.
As we wrap up this explainer, let's try a quick real-world thought exercise. Knowing how extreme consumer sensitivity mathematically locks up these market variables, ask yourself, if you were a supplier trying to grow a business, would you rather face a market built on a flat floor, where you can literally never raise your price, or a vertical wall, where you can never expand your overall sales volume? It's a pretty tough choice, for sure, and it shows exactly why understanding these geometric economic extremes matters so much in the real world. Thanks for exploring these graphs with me today.